Hello friends, and welcome you all in our another exciting video of a crossover platform. So let's start. Friends, you can see here there is one reference drawing for the crossover platform, and you can see the elevation and top view of this platform. This one is our side view, and if we come in the interface of Tekla-Structure, then you can change the color of this grid line by selecting the grid. And suppose I'm selecting yellow color, then click on the grid and change the value of this grid according to our design data. The overall length is 5.5 meter, width is 800 millimeter, and elevation is 100 meter to 100.7 meter. Now you can edit the value of grid in the coordinate section. Here you can see the value of elevation. This one is our reference ground level, which is in 100 meter. Then you can see the 100.70 is our top of steel. Now we will put the same value in the grid section. In Z section we put here 00, 150, 325, 1070, and we copy all this value and put in the label and add the plus mark before all the digits. You can also change the extension of this line. Now modify it. Once you modify it, click on the fit model. Then you can easily see all the model in a single interface. Now go to the concrete section and select the slab. Pick the 4 different points to define the geometry of slab. Suppose this is our second point, third point, and fourth point. This is our concrete slab. By default, the thickness of this slab is 200 millimeter. And if you see the design data, it's near about 150 millimeter. So you can see here the concrete platform is 150 millimeter thickness, and the footing of the column is near about 325 millimeter. You can see the elevation along the grid line 1, 0, 150, 325 and 1070. This is our elevation. We are going to extend a little bit this concrete slab. The width of this concrete slab is little bit more due to the location of a stair. It's near about 2176, So we will take near about 2.5 meter from the edge of grid line 2. We will make a little bit bigger the concrete slab. So this is our overall concrete platform. The next step is to create the footing for the column section, which is near about 325 millimeter high. Again, we go to the slab. Move to the top view and again select the slab. By default, we are taking 300 millimeter size of this slab. Later we can edit it according to the size of base plate of the column. This is our first footing for the first column, and again we can you can move it to the top of the slab platform. Now we are going to change the value of this slab. It should be 325 overall size, and if we add the value of 150 for the concrete platform, then it should be 175 millimeter. Now copy this slab and move it to the grid line B. Now our both footing are ready. Now we are going to place the column in that location. So go to the steel, select the column, select the bottom point. Then you can see the by default one column is created. If you see the profile of this column is UC 152. Now go to the eye profile and select the parallel flange UC 152 23 kg. Copy this value. You can also change the color of this column. Now move the work point from this point to here. Copy this column and place it to another grid. Now our both columns are ready. It's in first grid. We need to move it to the middle point of grid line 1 and 2. Now select the column and pick the middle point and move it to the midpoint of the grid. Now we are going to place the beam. If you can see, this one is our UB 203 23 kg. Now select the beam in steel section. Pick the first point and last point. Change the profile This one is a UB203. Now again select another beam by picking first start and end point. This beam is our channel, so we need to go to C profile. Again I am selecting ISMC 200 and we are going to change the work point. And suppose I going to change the rotation of this beam from top to below. You can also change the color of this beam to easily identify. Once you created the first beam, you can copy this beam to mirror from reference point. We are going to extend the previous beam according to the channel. Now set the UCS and select the beam. Go to the copy special and select mirror. Pick the access point, start and end point, then copy it. Again we will extend little bit this beam to cover the entire channel. Okay. Now we need to create the bracing, horizontal bracing of this for this platform. This is in 6 equal part and overall length is 5.5 meter. So first of all we are going to create 5 equal points to equally divide this grid. Pick the first point and again pick the last point. Then you can see 5 equally spaced points are created here. Select the construction line and create 5 lines here. Now again go to the beam. The size of this angle is 60 by 6 millimeter. Go to the steel, select beam, start and end point. Now go to the profile. We will select here the angle profile. Equal angle we will select here. You can also change the work point. By default it's taking in the middle point. Change the color for the bracing. Once you created the first bracing, you can copy this bracing and put this bracing in all reference line. Now again go to the beam and again select the angle profile and pick the middle point of this beam. In the similar way you can create the this one is our start and this one is our end point. The overall wireframing of this platform is almost created, and the level of this horizontal bracing is a little bit down. So pick the first point and again select the perpendicular point and move it to near about 75 mm down. Delete this construction line. Now you can see here all the wireframe of this platform is created. In our next video we will create the connection of this beam and column. So stay with us friends, and we will see in next our video. So thanks for watching, and if you like this video then please subscribe our channel and share with your friends. Thank you friends.